Okay, so I'm going to do the next ranking task. It's labeled 178, posted on our Canvas page. And in this problem, they say all resistors in the circuit, they're identical, 2 ohms each. The batteries are identical with either 6 or 12 volts. The connecting wires have negligible resistance. And you have to rank the current passing through the upper right-hand corner of each circuit from greatest to least. And you look at where they indicated to measure the current, but then you think, well, this is a series circuit. It actually doesn't matter where I measure the current. Anywhere in a series circuit, the current will be constant because you only have that one path for charges to flow. So that piece of information is actually like extra that we don't even have to pay attention, because if we find the total current, we know the current everywhere in the circuit. All right, so we have to do a little math for each one of these and pay attention to the number of resistors and also the voltage supplied at battery. So if I do I equals V over R, and then I just look at the number of resistors for each one, calculate the REQ, and divide the total voltage by the REQ, I'll get the answer. So this one is 6 ohms, 2 ohms, 4 ohms for this side, and this one is 2 ohms, 4 ohms, and 6 ohms again. Okay, so now we're just going to divide out. So 12 divided by 6, let me write it in red so I can actually see it. This one would have 2 amps because we're doing B over R. Over here we would have 12 divided by 2, so this one would be 6 amps. 12 divided by 4, so we would have 3 amps. 6 divided by 2, so we would have 3 amps, so we have a tie. 6 divided by 4, which is 3 halves, or 1.5 amps. Then we have 6 divided by 6, so this one would be 1 amp. Okay, so our greatest one would be C, followed by our tie of B and E. And then we would have A, then D, then F. Okay, so that's my ranking of current for these different series circuits.